Hello and welcome to this module, module 11. In this module, we are going to see about the second part of your register transfer level components, specifically the sequential part. So the first component that we are going to see is a register. So a register basically is a group of latch or flip-flop which has a common load or a clock signal. So the load pretty much enables each individual flip-flop or a latch, and then if it is made up of a flip-flop, then the clock signal, whenever you have a rising edge or a falling edge depending on your flip-flop, will either load the value or change the value in each individual flip-flop, and all individual flip-flops will simultaneously change the value. So the register is commonly used to store or shift binary data. So if it's simply used to store the data, then we call it as a buffer or a buffer register. In that case, it is mainly made up of a latch. If you're using it to actually shift a binary data, then it is made up of flip-flop, and it's called as a shift register. So in some cases, whenever you have a shift register, we also have some register ICs that have built-in latches. So you also have a shift register followed by a latch so that it can hold on to a value and you don't find the transitions when the actual shifting happens. So here is an example or a block diagram of a 4-bit register. As you can see, it has a parallel load. This internally is made up of these 4 flip-flops, and you can see it also has a clear signal so that it can clear the values to 0, and the load signal will basically load these values on your inputs to the outputs, and then in the presence of a positive edge of the clock. So here is your truth table of your shift or of your 4-bit register. So as you can see, when it's clear as 1, it resets all the registers to 0. When you have a value of clear and load is equal to 0, then there is no change, and whenever your load is equal to 1, then on the rising edge of the clock, the value in your inputs are loaded to your output. So here we see how we can transfer the values from 2 different flip-flops or 2 different set of flip-flops to 1 set of flip-flops. So we use your tri-state buffers. So this is an example of how a register to register transfer will happen. So as you can see, whenever we have an enabled signal which is equal to 1, then we can see that these buses are active. So the value of A1 will be pushed into D1, and the value of A2 will be pushed into the value of D2. And then when you have the rising edge of the clock, those values will then appropriately be moved to Q1 and Q2. So when you have your enable is equal to 0, so your enable bar here will be equal to 1, then we see that these 2 buses are active, and therefore B1 and B2 are moved to D1 and D2 respectively, and then in the rising edge of the clock it is moved to Q1 and Q2. So that's how you can actually select between 2 banks of flip-flops, and you can actually guide them to a respective latch or a respective flip-flop. Then next we see about shift registers. So with shift registers, we basically shift binary data in your flip-flops either to the left or the right. So we can basically indicate when we want to do a right shift operation, we indicate it by that symbol, and the number here denotes that the number of bits you want to shift it. So here we shifted one bit to the right. So again, if I use a left shift operation, so that's my left shift symbol, and let's say if I put a symbol 2, so then you want to basically shift the bit 2 places to the left. So for example, if we have a value which is 0, 1, 1, 0, and when we are trying to do a left shift of 1, then the data becomes 1, 1, 0, and typically 0, because you would be we assume that we're going to shift it left, and we're going to stuff zeros to the left. Similarly, if I have a value 1, 0, 1, 0, and I'm just going to do a right shift, and then you can see here the resultant would be 0, 1, 0, 1. As you can see that I have actually performed a right shift operation of a value 1 bit location. So another way of looking at this is by an arithmetic operation. So as you can see, whenever I have this value and I do a left shift of 1 unit, so basically you are trying to multiply that number by 2, and then similarly when I have a number and I do a right shift, then you're basically trying to divide the number by 2. So those are your arithmetic equivalents of performing your right and left shift. So in the next slide, we are going to see about a 4-bit shift register. So in this 4-bit shift register, we also have a serial in and a serial out. So here we basically are going to perform a right shift. So whenever we perform a right shift, so what is going to be is whatever the serial in value is going to be pushed into Q3. The current value of Q3, which is nothing but D2, is going to be pushed into Q2, and whatever the corresponding value in Q2, which is same as D1, will be pushed, and whatever this value will be pushed. So currently we have a value which is 0, 1, 0, 1, and since we have a serial in which is 1, so when we perform a right shift operation by 1, so the resultant value will become 1, 0, 1, 0. And let's say you still maintain 1, so as shown here, so here you can see that we have your serial in as 1, so we get a value 1, 0, 1, 0, which is what we have here. So here again we have a value which is 1. When we try to perform the next shift operation, you're going to get a value which is 1, 1, 0, 1. So that's what is going to happen here, 1, 1, 0, 1. And now at this point we have a shift in is equal to 0. When we perform that, you're going to get 1, 0, 1, 1, 0. So that is 0, 1, 1, 0. And then at this particular point, you can see that we again have a shift in value of 1. So when we perform it, it's going to be 1, 0, 1, 1, and so on. So that will be your final value as far as this input, the serial in, which is going to be 1, 1, 0, 1. So we can also perform a left shift operation, but then we need to actually modify this circuit. So then you can also have shift registers that perform left shift operation, a right shift operation, and then we can also have a left rotate, where you can see that when we left shifted, this value is moved back in there. So that's called the left rotate. And then we can also have a right rotate, where this value is going to be placed onto this value, which is going to be right rotate. So you can actually have some kind of a shifter, a universal shifter that performs all these 4 operations, and then also performs the load operation by default. So you will have all these functionalities in a particular shifter, which is called as a universal shifter. So here is another type of shifter, which is called a parallel in, parallel out, and it also performs a right shift operation. So here you can see what the parallel in does is that the values in D3, D2, D1, and D0, whenever you are actually going to give the load signal, which is this L, when that is active, so all these values are going to go through Q3. So D3 is going to go through that. So D1 is going to go through that. So D2, same with D1, and then with D0. So that's basically what you get as a parallel in, a parallel out functionality. And now coming to the shift operation of it, which is basically it only does a right shift. So here you can see when you do a right shift, the current value of Q0 will go out. Q3 is placed on Q2, is then placed on Q1, Q1 is placed on Q0, and the Q0 value is simply discarded. So now, as you can see, what will happen is we have the SI value. So that SI value goes in and is pushed into Q3. Simultaneously, the Q3 value will be taken and moved into Q2. And then Q2 value is taken and then moved into Q1. And then similarly, Q1 value is taken and moved into Q0. So therefore, that's the shift operation that happens. So that's when you have the SH signal, which is active. So we actually select the condition on your mux, which is 0, 1, and that 0, 1 enables us to actually do the shift operation. In the other case, wherever you have, for example, 0, 0, so whenever you have 0, 0, so we are going to use the first input of your mux. So here you can see that we are going to take this value and simply recycle it. So it's actually Q3 will be its current value, Q2 its current value, and so on. So therefore, what happens is you will be holding on to the same value, which is nothing but no change. Next, we see another variation of your shifter. So here again, you have a parallel in and parallel out shifting. So that's when your condition is 0, 1. And then as you can see, whenever you have a condition which is 0, 0, that it's actually retaining your value. So whenever you have 0, 0, here you can see this is the loop that it actually takes. And whenever you have for the parallel load, when it's 0, 1, so therefore we take this value, comes in, goes like that. So that's your parallel load. And then we have the right shift operation. So for the right shift operation, you can see that we are going to shift, let's say D3 will move to D2, D2 will move to D1, and so on. So here you can see the D1 value, which is here, is going to go in here, going to go through the 2 and into Q0. So therefore that becomes your right shift operation for 1 0, and then whenever we want to do a rotate, so in the rotate, so what actually happens is now the D0 value will need to be passed on to D3. So here you can see that this value, which is in D0, will go through this up into this, and then through the last condition, which is 1 1, will flow and be placed in Q3. So therefore that's how you basically get the rotate operation, or the right rotate operation in this case. So you can actually see an animation, or the signal flows again. So as you can see, whenever I have 0 0, so that will be the value that is retained, and then we have a value which is 0 1, which is the parallel in, parallel out. 1 0 is simply the right shift operation, and then when we have the 1 1 condition, the Q0 is now placed on to Q3 through the red loop that is shown. So here is a universal shift register. As you can see, here we can have the functionality where we retain the value or parallel load, and we can also do a left shift and a right shift operation simultaneously. A more complete universal shift register will also have the rotate right and the rotate left operation too. But in this case, we just limit our universal shift register to the shift right and the shift left operation. So here you can see with respect to, we have seen how it retains the value, the parallel load, and the shift left. But here we will see how it actually does the shift left operation. So in the case of the shift left operation, the A3 is actually moved to A4. So the loop which is shown here in the blue is the path it takes for a value of 1 0 in order to move the value from A3 to A4. So the type of questions that a student can be asked is, for example, given this particular universal shift register, and let's say I want to load a value of say 1 0 1 1 into the register. So what would be the control signals? So therefore the control signals should be, if I want to load that value, so first I need to give those values in here, and then I need to make sure that in order to load the current value, I need to make my S0 S1 as 1 and 1, and that will mean that the value of I4 will be placed here, which will be 1 0 1 1 as shown here. Clear? So let's say if I've now placed this value, now if I do a left shift, and if I do a left shift, and let's say I have my serial in here, so if I have a value which is 0, what would be the resulting value, and what would be what are the signals? So therefore now this doesn't matter, so this is 0. So in order to perform a left shift operation, so I need to get in a value which is going to be 1 0 here, so that will perform a left shift. And when I perform a left shift, you can see that you should get a value which is 1 0 1 1 0, because you're actually moving this value into A1. This value will go here, which is that. This value will go here, that is A3 will become the 1, and then this value will go there, will become 0. So that's basically what you will get with Sin is equal to, or we call it S in left is equal to 0. Now with this value, so now what we are going to do is, let's say if your S in right is equal to 0 and you're going to perform a right shift, so what actually will happen is that what are the signals and what would be the resultant value. So we have a value which is here, which is going to be 0 1 1 0, and we need to do a right shift operation. So we need to give 0 1 here, and since our value is 0, so therefore we're going to push this value into here, will become 0, this will move here, this will move here, this will go there, and this will be done. So therefore you're going to get a value which is 0 0 1 1, and that will be what is your end result once you perform a right shift with right shift input, serial input as 0. So if you had a value of, if I now have the same right shift, but now I choose to have a value of 1 here, then you should get this as your result. And so we can actually perform any type of operation, which is the left and the right shift, and then we can also change the value with the parallel load.